This trajectory example is for nitrogen storage in the wetland I've just been describing on Coonung Creek. On the y-axis we've got nitrogen in kilograms stored. On the x-axis we've got time in years. We'll go back to 1880 when we first had urbanisation developing in the Box Hill area. 1992, the intervention is the construction of this wetland, and we've got the 2020 line here in the purple. So we've got about 40 to 80% of nitrogen is typically stored in these off-stream detention basins. For Coonung Creek, the sort of numbers we're looking at per annum for storage would be about 20 kilos per year, but it's quite hard to find numbers on that. But we'll start off with that sort of value. So remember, this is storage. It's not load or delivery. It's what we're actually storing in the wetland. That means that as we start off back in 1880, as we have a high nutrient load, but a very small proportion of it's actually stored in the river or the floodplain. It's all going through to Port Phillip Bay down the Yarra. So we've got low storage down here, and then it's unlikely to change. In fact, as the system gets channelized, we're likely to get less storage even coming down. Then we build the wetland, and straight away we'll start to store some sediment, and a lot of nitrogen is associated with sediment. A lot of it's in solution. What happens? We have we need some denitrification processes or storage processes. The storing sediment in the floor of the wetland leads to denitrification, and it's lost to the atmosphere. Or you can store the nitrogen in the plants. So both processes are going on. So when we first build the wetland, it takes a while to start storing. Then we start storing some sediment. And then as the plants begin to store, we get an increasing rate. It starts to accelerate, and we'll get increasing storage up to here. Then what will happen is, from the do-nothing case, if we don't maintain it, what can happen is you can suddenly flush all of that plants and the material out. It gets saturated, and they start to become less effective. And it become less effective, and you can even have a sudden storm which will flush all the nutrients out of the floor. It'll go down like this, and then you might do some maintenance, and it might come back up again, and then it will stabilise at this point. Therefore, this is one trajectory for nitrogen in storage. It depends a lot on maintenance. And I'll send around a paper by Payne, P-A-Y-N-E, about storage or removal of nitrogen. It's a super complicated issue. I'll send a couple of papers around about that. Thanks.